Or not his face. So the sum shortcut formula for today, because these are geometric, and remember a geometric series, I had you write that down before. A geometric series is just the sum of a geometric sequence. And so I can move my board in a minute so we can figure out what these things stand for. But to find the sum, the shortcut for this one is we're going to take the first term times 1 minus r to the nth power over 1 minus r on the bottom. Or if you prefer, some people like to flip it around for their calculator. They like to flip these two things around. So it might also be a sub 1 out in, it can be also out in front or on the top, doesn't matter. You could have it r to the n minus 1, but then on the bottom, it would also be r minus 1. Okay, so in this case, because these are geometric, what do you think a sub 1 stands for? First term. And what does r stand for? Common ratio. And n stands for the number of terms. Okay. So I don't really care. We've done a sum with the expanded form earlier with summation notation. I'll show you what that looks like. But what I can tell you for these kinds of things is we don't need the last term anymore. But sometimes the last term might tell us how many terms there are, okay? If it's written in summation notation, you can figure out the number of terms by just looking at the index there. So let's write out some of these terms just so we remind ourselves what summation notation looks like and what it means. And then we're going to use the shortcut formula. So if I wanted to figure out the first term of this, yes, I could plug in 1, but the first term in a geometric sequence, pull this down a second, is also always going to be right here in front of the multiplier, okay? And so the first term of this is 1/2. And what are these terms being multiplied by? 3. So like the next term would be 3/2, and the next term would be 9/2, and so on, okay? All right, so the shortcut for the formula requires that I know what the first term is, which I know what it is, it's 1/2. And I know what the r is. The r is 3. So this is like my a sub 1. This is my r. And then the number of terms, if it's going from 1 to 10, would be 10 terms. So putting this in the shortcut formula, the sum is going to be equal to 1/2 times 1 minus 3 to the 10th power over 1 minus 3. And you're welcome to use the other formula if you want. If you're going to use this formula, just make sure if you're going to break it up into smaller chunks that you don't round it all. I strongly suggest using a calculator and using parentheses. So this is one of those deals, guys, where there's a lot of calculator errors. So I encourage you to get a calculator out so you're putting this in correctly. So I'm going to just go ahead and type in 1/2. I have 1 minus 3 to the 10th. And then on the bottom, I'm making sure that I'm dividing by 1 minus 3, which, by the way, what is 1 minus 3? Can I just say that it's -2? Okay, that might cut down some errors. All right. So would you confirm that you get for that sum that it is 14,752? I'll give you a second to make sure.
62.
Yeah, what did I just say? Oh, oh, you probably want Jolly Ranchers. What the crap? 14,762. All right. What if we're dealing with a fraction as a multiplier? Then I would make sure I am being real careful about putting that in my calculator. So let's identify. Would you just write down on your piece of paper, what do you think the first term is? What do you think the ratio is? And how many terms do you think there are of this one? I'll give you a moment. Okay. So checking in with me, I got 3, 2/3, and 7. Did you get the same? Okay. So when I'm using my shortcut formula, I have my 3 times, this is where I'm going to be careful. I need to put 2/3 in a parenthesis, so I'm raising the whole thing to the 7th power. I just want to make sure I'm real careful with that. And then I have 1 minus 2/3 on the bottom here. So I go ahead and put that in. And like I said, I just need an added set of parentheses. So I'm making sure that I'm raising that whole 2/3 to a power, and then I need another parentheses that separates the whole top there. And on the bottom, if you want, 1 minus 2/3 is 1/3, but if not, you can put in 1 minus 2/3. It should calculate it for you. You don't need a second parentheses on the bottom for that one. The only reason we need it on the top is because we're raising it to an exponent. All right, and so I get 8.4732510. Can you confirm you get the same thing? Okay. I will tell you that there is a way that you could do this and leave it as a fraction, but it's going to involve like 2 to the 7th and 3 to the 7th, so I'm going to just go ahead and leave it as an approximate decimal. Okay. And then I'm going to just do one of these application problems on the back, and then we'll talk a little bit more about the application problems on Thursday. Tomorrow I will be gone with graduation stuff, so but I'll be back on Thursday. So let's take a look. Let's go back to, we'll just do one of these, and we're going to do an arithmetic one. So I'm going to take a look at the top. We have a pyramid of cans on display in a supermarket. This might be outdated. I don't know if they still do this anymore. And they like have display tables that sometimes, they don't always have cans, but the top row has 1 can, the second row has 2 cans, the third row has 3 cans, and so on. Okay. So this is my sequence here. 1 plus 2 plus 3 plus ... And there are 10 rows of cans. Okay. So this is arithmetic, because what's happening is every time my row gets 1 more bigger, right? Okay. So if I'm looking at my sum formula for an arithmetic series, because I want to find all the cans, I'm going to need to know the first cans in the first row, the cans in the last row, and the number of rows, and divide by 2. All right, so using the shortcut formula, how many cans are in the first row? Depending on how you're looking at it, 10 or 1. Then how many in the last are Okay, so either way, we got 1 and a 10. 1 at the top, 10 at the bottom. Okay, so that's my a sub 1 plus a sub n. How many rows total? 10, and we divide that by 2. So we have 11 plus 10, 11 times 10, divided by 2. That would leave us with a total of 55 cans in that row. Okay. Let's take a look at one that's geometric. And then we'll stop for the day. So a student is constructing a family tree. He is hoping to trace back through 10 generations to calculate the total number of ancestors he has. Determine the total number of ancestors after the 10th generation. Okay, if a student is hoping to conduct a family tree, then they're going to, like, this is the student. And the student wants to go back, and the student is going to have to come from 2 parents each, right? And then those parents come from 2 more. So, like, if I went back, he'd have 2 parents, and then each of those people, I should have made that maybe bigger here. I'll put this. There's you. 2 parents, and then each of them are going to have 2 parents, yes? So, isn't this family tree going to be multiplied by 2 every time? Okay, and there's there's just 1 person at the beginning. So a sub 1 would be 1. What's r? What are these being multiplied by? 2. And then I want to know the 10th generation. So that would be 10. Okay, would you plug it in the shortcut formula to figure out the geometric sum? Did you get 1023 for the total number of ancestors when you plug that in? Can you check that you get 1023? Yeah, okay.